All right, let's dive right into one of the biggest, most mind-bending questions you can possibly ask. Just how big is the universe?
On the surface, it seems like a pretty simple question, right? You'd think we could just get out a giant cosmic measuring tape and figure it out. But the truth is, the answer is so much weirder, so much more complex, and honestly, way more fascinating than you can even imagine. This is going to be a trip.
So why is it so tough to answer? Well, it all boils down to two really incredible facts about our reality. First, the speed of light isn't infinite. That means every time we look up, we're actually looking back in time. And second, the fabric of space itself isn't just sitting there. It's stretching, and it's carrying everything along with it for the ride.
Okay, so here's our game plan. We'll start with why this question is so tricky in the first place. Then we'll explore our little cosmic bubble, the part we can actually see. After that, we'll solve a huge paradox about its size, uncover the 95% of the universe that's totally invisible, and finally we'll tackle the biggest question of all.
Right, so first things first, every single time you look at the night sky, you are literally a time traveler. You're not seeing stars as they are right now, you're seeing them as they were in the past. I mean, the light from the closest star to us took over 4 years to get here. And the Andromeda Galaxy, that light has been traveling for 2.5 million years. So you got to remember this key idea. When we look far out into space, we're also looking far back in time.
So, this cosmic time delay creates something called the observable universe. Think of it like a bubble with us right in the middle. Now, this isn't the entire universe, not even close. It's just the part of the universe whose light has actually had enough time to reach our eyes since the Big Bang. And we're at the center of our bubble, not because we're special, but just because that's where we happen to be looking from.
We know that the starting pistol for this whole cosmic race, the Big Bang, went off about 13.8 billion years ago. That's the age of the universe. So logically, you'd think our bubble must have a radius of 13.8 billion light years, right? Well, this is where things get really weird.
Get a load of this number. The diameter, the distance from one edge of our observable universe to the other, is a whopping 93 billion light years. Now wait a second. How is that even possible? If the universe is only 13.8 billion years old, how could something be 93 billion light years away? Did light break its own speed limit? This is a fantastic cosmic puzzle, and the answer is one of the coolest things in all of science.
And just so you can wrap your head around the sheer scale of what's inside this bubble, astronomers think there are something like 2 trillion galaxies in there. 2 trillion. Our own Milky Way, with its hundreds of billions of stars, is just one single tiny drop in this unbelievably vast cosmic ocean.
And this cosmic ocean, it isn't just a random splash of stuff. It has a structure. It's called the cosmic web. You've got these huge filaments made of galaxy clusters, and in between them are these massive, almost empty regions called voids. And the oldest light we can possibly see, the very edge of our vision, is this faint glow left over from the Big Bang itself, the cosmic microwave background.
Okay, time to solve that paradox. How in the world do we get a 93 billion light-year wide universe in just 13.8 billion years? Well, here's the secret. It's not that the galaxies are flying through space at impossible speeds. It's that space itself is expanding, stretching, and carrying those galaxies apart from each other.
And this is the classic way to picture it, because it works so well. Imagine you draw a bunch of dots on a balloon. Those dots are galaxies. Now, as you blow up the balloon, all the dots move away from each other. They aren't walking around on the rubber surface, right? The rubber itself, space, is stretching between them. So, that ancient light that's been traveling toward us for billions of years had to cross a stretch of space that was itself getting bigger and bigger the whole time. That's how we get to 93 billion.
Now, this stretching of space creates a really fascinating, kind of sad limit. The observable horizon is just the edge of what we can see today. But because this expansion is actually speeding up, there's also something called an event horizon. This is a point of no return. Galaxies that cross this line are being carried away by expanding space so fast that their light will never be able to reach us, no matter how long we wait. They are, for all intents and purposes, gone from our universe forever.
So, we've been talking about trillions of galaxies and this mind-boggling scale. But I've got to tell you, now we get to the most shocking part. Everything we've talked about so far, every star, every planet, every galaxy, all of it only makes up 5% of the universe. Yeah, 5%.
I mean, just look at this chart. It's wild. It completely reframes our place in the cosmos. Our entire reality is dominated by two things we can't see, and we barely understand: dark matter and dark energy. They make up the other 95% of everything.
Okay, so what is this stuff? Well, dark matter, which makes up about 27%, is like the invisible skeleton of the universe. We can't see it, it doesn't give off any light, but we know it's there because we can see its gravity at work. It's basically the cosmic glue that keeps galaxies from spinning themselves apart, and it's what forms the underlying structure of that cosmic web we talked about.
And then you have the biggest mystery of all, dark energy. This stuff makes up a whopping 68% of the universe. And honestly, we have almost no idea what it is. It seems to be some kind of energy woven into the fabric of space itself, and it's acting like an anti-gravity force. It's literally pushing everything apart and causing the expansion of the universe to speed up. Dark energy is the engine that's pushing those galaxies past the event horizon, forever out of our reach.
All right, so we have a pretty good picture of our observable bubble and the mysterious dark stuff that fills it up. But that still leaves the biggest question of them all. What about the entire universe? What's beyond the edge of what we can see?
We don't know for sure, but the theories are just amazing to think about. One idea is that the universe is finite, but it's so ridiculously big, maybe 250 times larger than our observable bubble, maybe even way more, that it might as well be infinite. Another idea, which our best data currently supports, is that space is flat, which would mean it's truly, genuinely infinite. And then there's the wild card. Maybe it has a complex shape, like a giant three-dimensional donut. If that were true, you could fly in a straight line forever and eventually end up right back where you started.
So, what's the ultimate fate of it all? Well, thanks to dark energy, the most accepted idea is that the universe will just keep expanding forever. Galaxies will get farther and farther apart, the stars will eventually burn out, and everything will cool down until the universe becomes this cold, dark, and unimaginably empty place. It's a future that's sometimes called the Big Freeze.
So let's just do a quick recap of these absolutely mind-blowing numbers. The universe is 13.8 billion years old. Our view of it is 93 billion light-years across. Everything we can see and touch is just 5% of what's out there. The other 95% is a complete mystery. And the true size of the whole shebang? It's at least 250 times bigger than what we see, and very possibly, it just goes on forever.
And I'll just leave you with this one last thought to chew on. If the universe really is infinite, but the number of ways you can arrange particles is finite, then doesn't that mean that eventually things have to repeat? Somewhere out there, far, far beyond what we can see, could there be an exact copy of Earth, with an exact copy of you, looking up at the stars and wondering this exact same thing? It's a staggering thought. Thanks for coming along on this cosmic ride.